Greetings, fellow Earthling. You and I stand here on Mars, where we've been sent from planet Earth to initiate one pretty hefty task: to terraform the red planet. Terraforming entails changing the physical characteristics of a planet or a planetary body to make it so that humans can live there. Those physical properties can include temperature, atmospheric composition and pressure, topography, or really anything that might prohibit human life. You may be thinking, that has got to be a really complex and sophisticated process. And you'd be right, logistically anyways. But in reality, the principles are quite simple. In the Martian case, there are really only three main issues that we must overcome: heating the planet, generating a magnetosphere, and introducing a biosphere and atmosphere. The average temperature on Mars is about minus 60 degrees centigrade, and that keeps all of the planet's water locked in ice sheets at the poles. For us to be able to survive, though, we need liquid water. So how could we heat the planet to melt those ice sheets? The answer may actually lie in a process that has a bad rap on Earth right now. The greenhouse effect, simply put, is the result of when certain gases in a planet's atmosphere allow the sun's radiant energy to pass through and heat the planet, but then don't allow that heat to escape back into space. Mars' atmosphere is only 1% the density of Earth's, though, and is composed of different gases, so we must be creative in our approach to initiating the greenhouse effect there. Lucky for us, there are vast clumps of solidified carbon dioxide, a greenhouse gas, present at the Martian South Pole. Theorists have suggested that we might be able to cause it to sublimate, or vaporize, and enter the atmosphere if we were to launch big mirrors into the planet's orbit, and have them reflect sunlight directly onto the South Pole, which could kickstart the greenhouse process. So far so good, right? Yes! And no. That same wonderful ball of plasma that makes the solar system go round, the sun, also exudes some really dangerous radiation. Astrophysicists call it solar wind, and it consists mostly of charged particles. This wind constantly streaks across space, ionizing and sweeping away whatever planetary atmospheres it may come into contact with. That is, unless that planet has a strong magnetic force field called a magnetosphere. The magnetosphere that keeps Earth's atmosphere safe from solar wind is produced by something called the fluid dynamo effect, which is a result of the Earth's liquid core being rotated about its axis. But oh wait, Mars doesn't have a magnetosphere or a liquid core to support one, and without those, the components of the greenhouse effect will just be whisked away into the cosmos. This may be the only time in history when atom bombs are actually a good answer. If we could detonate a series of thermonuclear charges in the core of the red planet, we could potentially liquefy it and thus create a magnetosphere via dynamo theory. Alternatively, I propose that we employ a system of satellites to orbit Mars that could generate and conduct an artificial magnetic field around the planet so as to act as a remote shield against such destructive solar wind, in the same way a dynamo would generate an actual magnetosphere. The last vital step is to introduce a biological factor. We could create contained pressurized ponds in which we could culture bioengineered photosynthetic microorganisms, such as cyanobacteria and other algae, and slowly introduce oxygen into the atmosphere until conditions are conducive for liquid water, at which point the autotrophs could be grown independently in the open atmosphere. To create soil, lichens modified to thrive in extreme conditions could break down the red rocks, while simultaneously changing the oxygen ratio in the atmosphere. The establishment of biogeochemical processes, including the nitrogen cycle, is what will ultimately lead to human habitability. Now, once we get started, experts approximate the process will take at least a few centuries, while some say it will take more like a few thousand years, so don't expect to see humans exploring Mars without a spacesuit in our lifetime. In the meantime, however, we scientists will be living in contained habitat structures, and by contributing to this mission of Martian terraformation, we will be sure that our legacy will live on as the beginning of the future for mankind. I really hope that you have been inspired to research and partake in the endeavor that will go down in history as our species' most remarkable feat of technology and science. Thank you.